The star at the center of your sky is the reason you are alive. It is also the single most dangerous object you will ever depend on. Every second of your life, the sun floods this planet with light and heat from about 93 million miles away, and it does it so steadily that you have never once had to think about it. But steady is not the same as calm. The sun is a churning ball of magnetized plasma, and its magnetic field is constantly twisting, tangling, and loading itself with tension. Every so often, that tension releases all at once, and when it does, our star stops being a quiet source of warmth and becomes some snaps. The sun does two things. First, it fires off a solar flare, a burst of radiation and high-energy particles. Moving only slightly slower than light itself, electrons and protons accelerated by the blast can electrify satellites and damage their electronics. Then, sometimes, comes the heavier blow. A coronal mass ejection. These are billion-ton clouds of magnetized plasma that take a day or more to cross the distance between the sun and Earth. Most of them sail past us into empty space. Some of them are aimed straight at us. And the ones aimed straight at us are the reason a small number of scientists spend their entire careers watching our star the way you would watch a very large animal that is, for the moment, asleep. Here is the strange part. You have almost certainly seen the gentle version of this already. The auroras, the northern and southern lights, are what it looks like when the sun's particles pour into our atmosphere and our magnetic field catches them. The same phenomenon that can burn out a power grid is the one that paints the sky green over Norway. It is beautiful and it is a warning, and they are the same events seen from the sun is really capable of. You have to go back to the year 1859. On the 1st of September that year, an English astronomer named Richard Carrington was sketching sunspots through his telescope when he noticed a sudden brightening on the sun's surface like nothing he had ever seen. He did not know it at the time, but he was watching the first solar flare ever recorded by a human being. It was a white light flare, a kind so rare and so intense that another one was not seen for over 50 years. Then the sky caught fire. 17 hours later, the auroras that as far south as Cuba. And across the Western world, the telegraph network, the closest thing that century had to an internet, failed and caught fire. Operators reported sparks jumping off their equipment. Some of them received electric shocks at their desks. In 1859, almost nothing in ordinary life ran on electricity, and the storm still reached around the planet and broke the one electrical system humanity had managed to build. That was the Carrington Event. It is still the benchmark, the storm that every later storm is measured against. And that fact should reframe the whole thing for you, because the damage in 1859 was done to a few thousand miles of copper wire on wooden poles. We now live inside a machine made almost entirely of copper wire. So the obvious question is the uncomfortable one. What happens if a storm like that arrives now? We have a partial answer, because one very nearly did. On the 23rd of July, 2012, a coronal mass ejection tore through Earth's orbit at the exact stretch of space our planet travels through. Scientists who studied it later judged it to be at least as strong as the 1859 Carrington Event, the most powerful storm in as much as 150 years. We were simply not standing in that spot when it passed. If the eruption had happened only 1 week earlier, Earth would have been directly in the line of fire. The only reason we have detailed measurements of it at all is that the storm cloud hit a spacecraft called Stereo A instead of hitting us, and that spacecraft recorded the blow the planet never felt. The people who reconstructed the event did not soften their language. Their models put a direct hit at a level comparable to the Carrington Event itself. Magnetic storm that knocked out the entire power grid across Quebec. One assessment of a Carrington-class strike on today's infrastructure estimated the total economic damage could exceed $2 trillion. And then there is the number that tends to stay with people once they hear it. A physicist working from the historical record calculated the probability that a storm this size would strike Earth within a 10-year window. The figure he arrived at was 12%. Here is the honest part, because this channel does not deal in panic. 12% is an estimate. Nobody can hand you the date of the next great storm. The overwhelming majority of solar activity is completely harmless, and the sun will very likely rise tomorrow and do nothing remarkable at all. This is not a countdown. It is a description of a natural phenomenon that has happened before, that will happen again, on a timetable the sun keeps entirely to itself. But hold that idea for a moment. The realization that our relatively well-behaved star, the calm one, the one that has let liquid water sit on our surface for billions of years, can still do all of this. Now look at what a genuinely violent star does to the worlds around it. Just over 4 light-years from here sits the closest star to our own. It is called Proxima Centauri, and it is a red dwarf, far smaller and cooler than the Sun. To your eye it would be dim, red, and utterly unremarkable. It is also, by any reasonable measure, a monster. On the 1st of May, 2019, a team of astronomers had 9 separate instruments trained on Proxima Centauri, some on the ground and some in space, across 40 hours of observing time gathered over several months. They caught the star in the act. For 7 seconds, Proxima surged from normal to 14,000 times brighter in ultraviolet light. Not 14,000 times brighter to your eye, but in the ultraviolet specifically, the exact band of radiation that breaks apart living tissue and strips the molecules out of an atmosphere. It was the largest flare ever recorded from our nearest stellar neighbor. 7 seconds. 14,000 times. Then it was over, and the star went back to looking dim and harmless. This is where it stops being a light show and becomes a story about a place, because Proxima Centauri has a planet. It is called Proxima Centauri b. It is roughly the size of Earth, and it orbits inside the habitable zone, the band of distance where temperatures could in principle allow liquid water to pool on the surface. On paper, it is the most Earth-like world we have ever found next door to us. The nearest thing to a second Earth that exists within any reach we can currently imagine. And it is being hammered. The scientists who study these flares estimate that Proxima's planets are struck by this kind of energy not once in a century, the way the Sun treats us, but at least once a day, and possibly several times a day. Over enough time, that much radiation can strip a planet's atmosphere clean off and expose anything on the surface to lethal doses. As one of the researchers put it, if there is life on that planet, it would have to look very different from anything on Earth. So sit with the comparison, because it is the whole point of this episode. 2 stars. The same underlying physics, the same magnetic machinery grinding away beneath both of them. One of them, ours, snaps hard enough every century or so to put our power grid at risk. The other snaps that hard several times a day, aimed squarely at the one nearby world that might otherwise have been a home. The gap between those two outcomes is the gap between a planet where a species can slowly build telescopes and start asking where it came from, and a planet whose air may already have been torn away before the asking could begin. The Sun's restraint is not a minor footnote in your existence. It is one of the quiet, unglamorous, endlessly overlooked conditions that had to be true for you to be here at all. That is the truth the title is pointing at. The star that could end everything in this solar system is the exact same star that started everything in it. Every plant you have ever eaten, every single breath, and it holds, coiled inside its magnetic field, the power to switch the modern world off in a single afternoon. Both of those things are completely true at the same moment. That is the real relationship you have always had with the object you are orbiting, whether or not anyone ever pointed out that you were in it. So here is the question worth leaving in the comments. If you genuinely knew there was a 12% chance, in the next 10 years, of a storm that could take the power grid down for months, would you want your country to spend billions? Is that a threat you would honestly rather not think about until it arrives? There is no clean answer, and that is exactly why it is worth arguing about. In the next episode, we leave the stars behind and turn the lens on you directly. We are going to shrink you, one step at a time, from the room you are sitting in out to the very edge of the observable universe, and measure exactly how small you turn out to be. The answer is worse than you think. The sun comes up tomorrow either way. For once, try to notice it.